Hello viewers, in today's class we are going to discuss a very fundamental problem in definite integrals involving greatest integer function, right? So this problem is a very easy one, and this problem is basically meant for the beginners who are studying definite integrals involving greatest integer function, right? So let us start. Now here we have the integral from 0 to 2 and 2x plus 1 divided by 3 plus greatest integer of x minus 2. Now here let us first call this integral as I, and here we see that in the denominator we have the greatest integer of x minus 2, right? So here we'll make use of the method of substitution, and here x varies from 0 to 2, and let us take y is equal to x minus 2, right? So we are now transforming this integral from variable x to y. So we are taking y is equal to x minus 2, so therefore dy over dx is equal to 1, right? And dy is equal to dx. Now let us change the limits, and here we have x is equal to 0. When x is 0, then y is 0 minus 2, that is minus 2, and when x is equal to 2, y is equal to 2 minus 2, that is 0, right? So when x varies from 0 to 2, y varies from minus 2 to 0, right? So now this integral I, it reduces to minus 2 to 0, and for 2x plus 1, so here we'll have x is equal to y plus 2, and here we can substitute for x we can write y plus 2, and here we have plus 1, and in the denominator we have 3 plus greatest integer of y, right? And for dx we can write dy, right? Okay, so now we can simplify it, and we have minus 2 to 0, this is 2y, 2 to the 4 plus 1 5, 2y plus 5, and in the denominator we have greatest integer of y plus 3 and dy, right? Okay, so now viewers, here we see that the limits of integration varies from minus 2 to 0, and between minus 2 and 0 we have the integer minus 1, right? So what we will do, we'll take this minus 1 as the point where we can break this integral as a sum of two integrals, that is I1 and I2, right? So I1 goes from minus 2 to minus 1, and I2 goes from minus 1 to 0, right? So now we can write minus 2 to minus 1, and we have 2y plus 5 over greatest integer of y plus 3 dy, and I2 is from minus 1 to 0, we have 2y plus 5 divided by greatest integer of y plus 3 and dy, right? So now let us first take this integral I1, and here we see that y varies from y is equal to minus 2 to minus 1, right? So y it lies between minus 2 and minus 1. So by the definition of greatest integer function, when y lies between minus 2 and minus 1, then the greatest integer of y is equal to minus 2, right? And similarly in I2, y varies from minus 1 to y is equal to 0. It means y lies between minus 1 and 0, and again from the definition of greatest integer function, the value of greatest integer of y is minus 1, right? So now for this term we can write minus 2 because y lies between minus 2 and minus 1, and for this term we can write minus 1, right, because y lies between minus 1 and 0. So now therefore I can be written as minus 2 to minus 1, and we have 2y plus 5 divided by minus 2 plus 3 dy, and here we have minus 1 to 0, and we have 2y plus 5, and we have here minus 1 plus 3, and here we have dy, right? So now we can simplify it further. So 3 minus 2 is 1, and we have minus 2 to minus 1, 2y plus 5 dy, and here we have 3 minus 1 is 2. So we can take half outside the integral. We have minus 1 to 0, 2y plus 5 and dy, right? So now we can easily find out the values of these two integrals. So now we have here this integral is 2y square over 2, because the integral of y is y square over 2, and we have 5y. Integral of 5 dy is 5y, and we have limits minus 2 to minus 1, and here we have half, and here also we have 2y square over 2 plus 5y, and limits are from minus 1 to 0. Here 2 and 2 get cancelled. We have y square plus 5y minus 2 to minus 1, and here 2 and 2 get cancelled. We have half y square plus 5y, and limits are from minus 1 to 0, right? Now we can substitute the limits, and we'll take the difference. So minus 1 square, that is 1, and here we have minus 5, and when we take minus 2 here, we have 4, then we have here minus 10, and here we have half, and when we take 0, so we have here 0, and then we have minus, when we take y is equal to minus 1 here, so we have 1 and minus 5, right? So this is minus 4, and this is minus 6, and here we have half, and minus and minus 4 is plus 4, right? So this is minus 4 plus 6, and here we have 2, and 6 minus 4 is 2, and plus 2, so we have 4, right? So therefore the value of this integral is equal to 4, right? So viewers, this is how we solve this basic problem in definite integrals involving greatest integer function.